Okay, so starting with the first chapter, which is engineering curves. Under this, we are going to study three types of curves. First is cycloid, second is involute, and third is helix. The helix is not been yet asked in the exam, so we will be focusing on cycloid and involute. So, starting with cycloid. Cycloid is defined as a locus traced out by a point on the circumference of a circle, okay, which is rolling on a straight line without slipping. So we'll directly start with the question and we'll see how to draw cycloid. A circle of 50 mm diameter rolls along the straight line without slipping. Draw the curve traced out by a point P on the circumference of the circle for one complete revolution. One complete revolution means the distance traveled on the straight line will be equal to the circumference of the circle. So the straight line which we need to consider is equal to the circumference. So I'll first start with the straight line, which is also called as directing line, because it is the path of the rolling circle. So it is directing that circle, so that's why it is called as directing line. So we'll draw first horizontal line along which that circle is going to roll. So obviously it should be maximum at the bottom because circle will be rolling above and curve will be also generated above this line. So this line is called as directing line. And we are assuming that the circle is going to roll towards right. So initial position of the circle should be on the left hand side. So nothing will come on the left hand side of the circle. So I'll start drawing the circle on the extreme left. So for drawing the circle, initially I should draw a vertical line exactly perpendicular. So suppose if I'm starting here, the diameter is given as 50 mm. So I'll mark the diameter equal to 50 mm on this line. So we are dropping a perpendicular on this line, which is a directing line, and I'll mark distance equal to 50 mm, which is the diameter of the circle, and also I'll mark midpoint of that, which is 25 mm. Okay. Now since the circle is rolling on a straight line, initial point of contact will be a single point with the line. So for that, we'll first draw the circle. So this distance, which is 25 mm, will give me the radius of the circle because diameter is given as 50. So with that radius exactly equal to 25, so circle is having only one point of contact with the directing line. Okay, so this is the initial position of the circle before rolling starts. Okay, now the next step is I should divide the circle into some number of parts. Now that number of parts will depend on the radius or diameter of a circle. If the radius is large, the maximum division, that ideal division should be 12 divisions. So I should divide that circle into 12 parts to get more precise curve. But here, since the radius is small, 25 mm, that circle is small, I can divide it up to 8 parts also. So for dividing the circle, if I draw a horizontal line parallel to the directing line passing through the center, obviously that line will divide the circle into 4 parts because we have already marked the vertical diameter. Now after marking the horizontal diameter, I am getting 4 divisions. Further, I need to have 4 more divisions. So I'll just mark the total angle is 36 degree, so 360 degree. So if I want to divide into exactly 8 number of parts, so I should have each angle equal to 45 degree each. So I'm marking 45 degree here, and also 45 degree from here. Only 2 markings is sufficient, because after producing through the center this 45 degree angle, it will obviously divide the circle on other side also. So I'm dividing the circle into 8 parts. For more precise answer, you can divide into 12 parts also, but it will again create number of points, number of lines, so it will be again confusing. So if the circle is small, you can take up to 8 divisions. Now I'll number these divisions, but before that I need to decide exactly for which point on the circumference I should draw the cycloid. Since it is not mentioned in the problem that where the exactly point P is lying, so for assumption we can say that point P is initially in the contact with directing line. It may be given that point P is here or anywhere on the circumference of the circle. But since it is not given, for convenience we can take point P in contact with the ground or directing line. And this circle is called as rolling circle. So the first step is drawing the directing line, then dropping a perpendicular, then drawing a circle of a given diameter, and then dividing into either 8 or 12 parts depending on the diameter of circle. Now I'll start numbering the divisions of the circle. So I'll go in the anti-clockwise direction. So from P, I'll start with 1, 2, 3, 5, 6, 7, and obviously 8 will again coincide with P. Okay. And the center of the circle is denoted by C. Now, as the circle is rolling along this directing line, the center position of the center is going to shift along the straight line only, passing through C, because only the point C is going to travel along the straight line. All rest of the points on the circle will follow the curve path. So initially I'll produce that center line, okay, along which I'm going to get new positions of the centers as the circle rolls. Now I need to fix the length of the directing line for one revolution. As we know that the circle is revolving for one complete revolution. So for 50 mm diameter, as we know, the circumference is 2 pi r. So for this length of directing line, I should first calculate the circumference, which is equal to 2 pi r, which is equal to pi d. So I can calculate that. So 3.14, which is pi, and d is given as 50. So that is giving me 157. Okay. So I have to mark that length of 157 mm along the directing line to locate the final position of the circle. So 155, 57. Okay. Let that final position be P dash. That means after one complete revolution, this P will again come to the original position, that is ground. So we have to show again. I can draw the diameter perpendicular from P dash to mark the final position of the circle. We can in advance draw the final position of the circle. Okay. So here again with the same radius, you can draw the circle, which is the final position of the circle. Now here no need to divide the circle like in original position. Okay, so now the next procedure is whatever in whichever number of parts, like here we are dividing the circle into 8 number of parts, so we should divide the circumference, that is revolution, one revolution length, also in same number of parts. So I need to divide this length 157 mm into 8 equal number of parts. So for that we can follow the acute angle method, which is just drawing a horizontal this inclined line, acute angle. Then on that line we are randomly going to mark 8 divisions. This method will give me the exact divisions, because it is not possible to exactly divide 157 into 8 parts. If you do it that on Calc, you will get some decimal numbers. So this method will give you the exact divisions. So 1, 2, 3, 4, 5, 6, 7. One more division. Our aim is to divide this length P dash, which is equal to the circumference, into 8 equal number of parts. So we are following this acute angle method. So as per this method, we should join the last division with the end point of that P dash. Now to mark the other divisions, I should draw the parallel lines. So obviously it will divide the original line into same number of parts. This method we have already learned in school geometry. So be careful while drawing the parallel lines. Okay. Now once you have marked one division, then there is no need to draw the parallel lines again, because you can take the same division. You have got one equal division. Okay, you can check whether the second division is also same. Yes, so you can continue with the same length to mark the remaining divisions, because drawing the parallel lines, if the scale is tilting slightly, it will give you the error. So what I'm doing is I'm taking the length of one division and marking the remaining divisions. So you can verify if the last division is exactly coinciding. Yes. So we have got the 8 divisions on the circumference length, okay, which is P dash. Now I'm going to give some notations. So we'll start with 1 dash, because 1 to 3 are already used. So we'll write with dash now. 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, 7 dash, and 8 dash will obviously coincide with P dash. Now as I said, when circle is rolling, only the point C is going to move along a straight line, the rest all other points are going to follow curve path. So now if the circle has covered 1/8, like we have divided circle into 8 parts, so if the circle has covered 1/8 revolution, the center will move from C to new position. Let that position be C1. So I'll get that position if I drop a perpendicular from 1 dash up to the center line along which the center is going to move. So similarly, after covering 2/8 revolution, the center will move to C2, continuing up to P dash. So 3 dash, 4 dash, 5 dash, then 6 dash, 7 dash, and P dash is already marked. So I can now write the new positions of center C1, then C2, C3, C4, C5, C6, C7 and C dash. Okay. Now the next step is to draw the horizontal lines from each division. Like if I start with first division, obviously since we are equally dividing the circle, it will again pass through 7 also. So division, I am drawing a horizontal line passing through first and 7th division on the circle and parallel to directing line. Similarly, from 2 to 6 is already drawn because it is again passing through the center. Then 3 to 5 to get a horizontal line, and then 4, the last point. Okay. Now when the circle has that center has shifted after 1/8 division from C to C1, the position of P is going to change. That means if the circle is rolling like this, P is going to move upwards. So for marking that new position of P corresponding to C1, corresponding to C, the position is original position is P. But when the circle has moved by 1/8 division with the new center, I have to mark the position of P. That is, new position will be P1. But we know C to P is always going to the distance of radius. Whatever is the position of a circle, new position of a circle, that C to P distance is not going to change. Only the position of C and P are going to change. So with new center C1, I can mark position of new position of P, which is P1. For that, I need to cut an arc on a horizontal line passing through first division, that is 1, because we are marking P1. So I'll get P1 on a horizontal line passing through 1. Similarly, so I can start naming. So this point is P1. Similarly, if I am moving to next center C2, I have to move to the next division of the circle, which is 2, and the horizontal line passing through 2 is this. Now the question is, with C2 I can mark 2 arcs on the center line, one here and one here. But we have to see the nature of P, nature of path followed by P. After P1, P2 will just move slightly upwards. It will not go on this side. So we need to see the arc, select the arc correspondingly. So P2 will be somewhere here. Similarly, P3 will go again. Again, we need to decide from division 3, horizontal line passing through 3 with center C3. I need to cut arc. Again, we need to decide which arc, this or on other side. Obviously, it will be on this side. So it is P3. When we have reached to C4, that means we have reached half of the distance of the circumference. So circle has rolled through half of the circumference, half of the revolution. So position of P will get exactly reversed. That means initially the point P was bottommost point. So after half a revolution, that will become exactly topmost point. So from C4, if you see, we are getting a tangent point. That means that P4 is the topmost position after reaching half of the revolution. Again, after reaching topmost point, that point P is not going to move further in upward direction. So it will follow the downward path now. From P to P4, it is following upward path, but now once it has reached topmost position, it will come down again. So from C5, while marking P5, again I need to check the next division on the division of a circle, which is 5, and horizontal line passing through that. I want to mark arc on that line. Again, there are two possibilities, here or here. But obviously when it is coming down, it will not come down like this, but this will be the appropriate arc. So P5 we are getting here. Again with C6 we need to come down by one division. So for 6 the horizontal line is nothing but the center line, so I'm getting P6. Again I can't get the arc here, so this is the right arc, so P6 we are getting here. With 7 C7, again we need to check the division, 7th division on the circle, so I'll get somewhere here, so this is giving me P7. And obviously with C dash, that P dash is already marked, which is the point on the ground. So after one complete revolution, P is again coming back to its original position, that is with the contact with the directing line. So now we have marked P, P1, P2, P3, P4, P5, P6, P7 up to P dash. Now after joining these all points by smooth curve, we'll get cycloid for point P. So for this, if your freehand drawing is good, you can initially join by smooth lines, or if your freehand drawing is not good, you can use French curve. Right now I'm not having the French curve, so I'll just draw by free hands. Initially you can draw it light, and if you feel that shape is right, then you can make it dark, because that is the required answer, so that should be dark. So I'm making that cycloid dark now. Okay, so this curve is nothing but cycloid, which is the required answer for the given problem. Now we can add further, like for the initial position of P was not given in the problem, so we can assume the initial position as the topmost position. So if you are assuming that topmost position, so after completion of one revolution, the point P dash will come again at the topmost position. So nature of curve will be, first it will move downwards, reach the bottommost position at 4th, that is exactly half a revolution, then it will again climb up to topmost position. So that the nature of curve will depend on the position of initial point, that is P, location of P. Now one more part one more question can be asked is to draw the normal and tangent to this cycloid. Okay, for this problem it is not asked. We'll see in the next problem how to draw the normal and tangent. So this is the basic method to draw any cycloid. So here again we need to show some dimensions, like diameter of the circle. So you can show like this. Here it is 50 mm, so notation is 5 diameter. Again you can show the directing length of the directing length between these 2 points by dimensions line. So this length, which we have already calculated as 157, so I can write pi d is equal to 157 mm. Okay, and this is the directing line. So this completes the solution for this given problem.